Hello everyone. In this lecture, I will discuss about the how to solve the deformation problem by using principle of superposition. Let's see the problem. A member ABCD is subjected to points loads P1, P2, P3 and P4 as shown in figure. Calculate the force P2 necessary for equilibrium if P1 equal to 10 kilonewtons, P3 equal to 40 kilonewtons and P4 equal to 16 kilonewtons, taking modulus of elasticity as 2.05 into 10 to the power 5 Newton per mm square. Determine the total elongation of the member. Here observe that the member ABCD is subjected to load not only at the ends and also at intermediate points. And one more thing, member is not having the uniform cross-section area and it is varying along its length. So here we have to calculate the force P2 for equilibrium and also have to find the total elongation. Let's see the solution. In equilibrium condition, we know that summation of the left hand side forces equal to the summation of right hand side forces. Here in the diagram we have to observe that So left hand side forces are the P1 and P3. So P1, 1 minute. So P1 and the P3. And right hand side forces are the P2 and P4. Then we have to write down that So P1 plus P3. So left hand side forces, summation of the left hand side forces, that is P1 plus P3 equal to the P2 plus P4. In the given data, that is given that P1 equal to 10, P3 equal to 40 and P4 equal to 60. Then substitute in this equation. So we will get the P2 equal to 34 kilonewtons. So next we have to find the total deformation of the member. So we know that principle of superposition is saying that deformation of a member equal to the summation of deformation of the individual section. So that is delta equal to summation of deformation of the AB section plus deformation of the BC section plus deformation of the CD section. First we have to find the deformation of AB section, that is the delta AB. For this draw a free body diagram of the AB section. So this is the free body diagram of the AB section, and we know that deformation of AB, which is equal to the P of AB, L of AB divided by cross section area of the AB section and E. Here P of AB is the net force acting on the AB section. For this we have to observe the left hand side or right hand side of the AB section and we have to find the net forces. Here we have to observe that from the left hand side, so only one force is acting, that is the P1. So here only the one force, that is the P1, and we have to observe the right hand side. Here we have to observe that So P2 tensile and P3 compressive and P4 tensile. So which is equal to the P2 minus P3 plus P4. So here in the left hand side only one force is acting, that is the P1. So nature is tensile, so then I have to consider the plus 10 kilonewtons. Similarly here, so which is the P2 in tensile, so that's why P2. So P3 in compressive, so minus P3, P4 in tensile plus P4. So net force is 34 minus 40 plus 16, so which is equal to the 10, so positive 10, so it is the tensile. So P of AB, which is where the value is, which is equal to the 10 kilonewtons, the nature is tensile. And also we know that so length of the AB section is given that the so 1000 mm. So 1000 mm, and cross section of the area of the AB section is, we have to determine, so pi by 4 d square. D is the diameter of the AB section. Here that is the given the 25. So here cross section area of the AB, which is equal to the 490.9 mm square. And the E value is given in the data, that is 2.05 into 10 to the power 5 Newton per mm square. So substitute all these values in the above equation. So we will get the deformation of AB equal to 0.099 mm. And one more thing you have to observe, that one, this deformation is caused by the tensile force. So elongation it will be occur, and the symbol you have to consider the plus symbol. Next we have to find the deformation for the BC section, that is the delta BC. For this one, draw a free body diagram of BC section. So this is the free body diagram of the BC section, and we know that one delta BC equal to the P of BC into L of BC divided by cross section area of the BC section into Young's modulus, that is the E. Here PBC is the net force acting on the BC section. For this, observe the left hand side or right hand side of the BC section and find the net force. Here we have to observe left hand side. So P1, so tensile force, and P2 compressive force is acting. So here, so P1 minus P2. Similarly, in the right hand side, we have to observe that one. So P3, that is in compressive, and P4 in the tensile. So which is equal to the minus P3 plus P4. So observe here, for the left hand side, you have to observe. So two forces are acting, that is the P1 and P2. So P1 is the tensile, so plus P1, and P2 is the compressive, so minus P2. Similarly, in the right hand side, so P3 in the compressive, so minus P3, and P4 which is the tensile, so plus P4. So net forces are, have to substitute 10 minus 34, which is equal to the minus 24. Similarly, minus 40 plus 16, so which is equal to the minus 24. So here P of BC equal to the minus 24. So which means, so the net force is acting as a compressive force. So here net force is acting as a compressive force. That is the PBC is minus 24 kilonewton, and length of the BC section is given in the data. So in the diagram we have to observe that one, 600 mm, and cross section area of the BC section is, which is equal to pi by 4 d square. Here diameter is given, that is the 50 mm. Then so I have to substitute pi by 4 into 50 square, so which is equal to the 1963.5 mm square. And we know that one Young's modulus E value is given in the data, that is 2.05 into 10 to the power 5 Newton per mm square. Here we have to substitute all the values, all the values substitute in the above equation of the delta BC. Then we will get the delta BC value is 0.036 mm. And one more thing here we have to note down. So deformation is occurred by the compressive force. So nature of force is compressive. So deformation is the contraction, and the value here we have to consider the negative value. So next we have to find the deformation of the CD section. So for this one, draw a free body diagram of the CD section. So this is the free body diagram of the CD section, and we know that one delta CD equal to the P of CD into L of CD divided by cross section area of the CD into Young's modulus. Here P of CD equal to the net force acting on the CD section. For this one, we have to observe the right hand side or maybe left hand side of the free body diagram. So first we have to observe the right hand side of the CD section, and we have to observe what are the forces are acting. See here, so up to here, this is the right hand side. So we have to observe here. So P1 in the tensile and the P2 in compressive and the P3 in the tensile is acting. So here in the right hand side, so which is equal to the P1, so tensile, P2 compressive, so minus P2 and P3 in tensile, so plus P3. Similarly, so in the right hand side you have to observe that only one force is acting, that is the only P4 force. So nature of the P4 force is tensile force. So here plus P4. Then you have to substitute all the P1, P2, P3 and P4 values. So net forces are acting on the CD section is 16 kilonewtons and the nature is the tensile forces. So 16 kilonewtons, so which is the tensile force. So P of CD equal to the 16 kilonewton. So tensile. So here it is the wrong. So sorry. So here so tensile and the length of the CD section is 800 mm. Already just have to observe the diagram. We will get the length of the CD section is 800 mm. And the cross section area of the CD section is pi by 4 d square. Here d is given that one, so 30 mm. So cross section area of the CD section is pi by 4 into 30 square. The value which is nearly it will become the 706.9 mm square. And the Young's modulus of the CD section is given in data is 2.05 into 10 to the power 5 Newton per mm square. So all these values substitute in the equation of delta CD. In this equation I have to substitute all the values, then we will get the delta CD equal to 0.0888 mm. And one more thing you have to observe that one. So net force is acting on the CD section is tensile force. So due to the tensile, the deformation is elongation, it will be takes place, and the symbol is you have to consider the plus symbol. And total deformation of the bar is so delta, which is equal to the deformation of the AB section plus deformation of the BC section plus deformation of the CD section. So all the delta AB, delta BC and delta CD, so we determined from the previous slides. So substitute all the delta AB, delta BC and delta CD values. That is the delta AB equal to the so positive 0.099 and delta BC is negative value of 0.036 and delta CD value is positive value of the 0.088. So substitute all these values in the delta, then we will get the total deformation is 0.151 mm. So which is the positive. So positive means if it is the elongation, it will be takes place. Thank you very much.